Thanks, everyone. So, like we were introduced, I'm Evan. I'm a senior software engineer at Dynatrace. My day-to-day responsibilities are mostly centered around contributing to and helping maintain the collector.
And I'm Pablo, also a senior software engineer at Datadog. And yep, I mostly do the same, maintain the collector.
So, before we get started today, I just want to quickly cover what we're going to go over. First, we're going to introduce the collector for anyone who's not familiar. Just a show of hands, how many of you in here are familiar with the OpenTelemetry Collector? All right, I like that. Cool. OK, so for those of you who aren't, we'll just give a quick intro just so that everybody's on the same page. After that, we're going to give an introduction to the OpenTelemetry Collector Builder, shortened to OCB. We're going to show you how you can use that to create your own distro with hopefully fairly minimal hassle. And then finally, we're going to go over a couple of tips that we have for what it takes to build a production-grade distro. So some more advanced use cases for those of you out there who have really particular needs around your collectors. So first, an introduction to the collector. The OpenTelemetry Collector is like basically an agent or an observability pipeline middleware, however you want to describe it. It basically sits in the middle of your telemetry pipeline somewhere, sometimes toward the start, but generally toward the middle. It helps collect data from anywhere. So anywhere that supports OpenTelemetry or a variety of other formats, you can use the collector to help get that data into your observability backend. Whether that's your applications, your infrastructure, it can handle the job. And one thing to note, the collector doesn't store this data. It's going to forward it onto a backend somewhere else. So inside of the collector, what you have are a number of components. So everything's assembled using pipelines. So it flows through the collector, and you can configure how the data flows through. So you have basically maximum flexibility. So it comes in through components called receivers. So these will take an input data format, whether that's syslog, Elasticsearch, some kind of metrics on your hosts, OTLP, you name it, and then it puts it into the pipeline where you can do any number of processing operations on it. So this might just be tweaking some fields, you might want to do some redactions, some sampling, et cetera. And then finally you put it into an exporter, and the exporters will translate it into an output format. We hope OTLP works for you, but any other output formats, or any number of other output formats are supported. And so in addition to these sets of components, there's a handful of others that the collector supports. So all of the collector's data processing is going to be modularized into these different types of components. They all fulfill a particular function inside of the collector, and they're all available, each as their own modules. So the collector is, you basically, when you build a distribution, you choose which ones you want, and then you assemble them together into a binary. And you can see a couple of examples of different types here. Like I said, you have receivers and exporters, which deal with translating data into the collector or out of it. Processors that help do some transformation or other types of operations. You can also have extensions, so these might help you do outside operations of the collector. Let's say you want to authenticate with a backend in a common way. Or things like connectors or config providers, which we won't get into here, but are one of the handful of different types of particular modules that the collector supports. So when you build all of these into a distribution from the libraries, you get what's called a distribution. So again, you choose from the different types of components you want, you build them in, and you get your collector distribution. And there are a couple of different types of distributions out there. So there's the upstream distributions. There's standard ones like the core distribution, which has a couple of open source supported input formats and output formats. The contrib distribution, which I'm sure a handful of you are familiar with in here, that supports just about everything that's upstream. And a handful of other ones for more specialized use cases like Kubernetes. There's also vendor distributions. A lot of observability vendors will offer their own distribution that is guaranteed to work with that vendor and will offer maybe some extra support since they have verified the components that go into it. And finally, the topic that we're on today, these are custom distros. So custom distributions are any distribution that a user builds for their own needs. And the key point here is that this offers maximum flexibility. You can pare it down to only the things you need. You can add extra things. You can do replacements. We'll get into all the details later, but These are really where the power of the collector comes into play. So, like I said, you build a custom distribution for your own purpose. There are over 200 open source components, and everything in the upstream distributions is open source. So you're free to just grab and put in whatever you want. Like I said, this is the way to get the smallest binary size. In addition to that, since you're not including code that you don't necessarily know about, again, the contributor distribution has over 200 components, so you're probably not going to go through and review every one of those. It also has the smallest attack area as far as any code that you're not so sure about. And you can do all sorts of other things as you're doing this. Let's say there's a fix in some upstream thing that you want to put into your distribution. You can pull it in early. You can maybe, let's say it doesn't do things quite like you want. You can also patch it, apply custom fixes. You can make your own components. Maybe you have an input or output data format that isn't supported. You can add that. And we'll go into this a little bit later, but you can also customize the build process. Maybe you want to add some instrumentation. Maybe you want a specific architecture or operating system that isn't supported upstream. That's also a possibility. So when you're building an upstream or a custom distribution, you're going to start with usually the upstream components. So somebody upstream will make a PR, those all get merged into main, and then every 2 weeks we cut a release. So actually, I think just yesterday, the v0.123 or v1.29 releases were put out. So you can use those as they come out. And what you usually do is use something like Renovate probably, or just manual updates to pull these upstream things into your custom distribution. So this is the collector core libraries, OCB, any components that you want. You'll run some testing on this, hopefully, to just make sure that everything works like you want. Make sure that there aren't any breaking changes, things like that. Finally, you'll cut your own release and publish artifacts to kind of wherever you want. That can be AWS ECR, the GitHub container registry, Docker Hub, you name it. And let's say upstream doesn't have something that you want, you can do a hotfix. So you can plug in your own code, you can patch something and make sure that it fits whatever security SLAs or other custom requirements that you have. So a quick aside, I'm sure at least a few of you are kind of wondering right now, okay, well, this seems like you have this modular system and this seems fine and all, but why not just bundle these into their own modules and you have those imported at runtime? Well, we've definitely thought about this. A lot of consideration and discussion and deliberation has gone into it, and there are just some difficulties right now. Basically, it's not really natively supported in Go. There are some things that kind of work, but not really. But the biggest thing is that it would dramatically affect performance. The collector is meant to be lightning fast and has been carefully designed to have the minimum amount of processing and memory requirements while processing your telemetry. And trying to pull things in at runtime would require writing this data in such a way that it just wouldn't be performant. So it's something that we're looking at and might come in the future. But for now, we've tried to patch around all of the difficulties that you might encounter when building a distro with OCB. And we hope that this will be a relatively painful process. So a quick introduction to the collector builder. The collector builder basically is supposed to automate as far as possible the process of building a collector binary from the input set of components that you want. So the only thing that you really need to build your own binary is a manifest and then an OCB binary. So your manifest, which we'll show in a minute, basically just has the list of components that you want. And OCB will take, using the collector APIs for the version it was built with, the top-level files that import these components and actually start the collector. It will template all of your components into those API code templates and generate Go code from that. And you can choose, if you really want, to not build that Go code on the spot, but what you'll do is you will take a Go binary that should be available on your system. It's not going to be bundled in with OCB. And that will just run the build process, the standard Go build process, on all of that Go code to produce the collector binary. And so like I've been saying, this offers a lot of flexibility. There's a lot of points of injection here where if you have specific requirements, there's still opportunity to customize it. But for standard use cases, it should be a pretty much one and done deal. So 2 config options that you'll probably want to consider. OCB has a handful, but pretty much everything you should be able to do fairly simply with the config file. One is the config flag. So like I said, all you need is a manifest. You just call the config flag, you give it the path to your manifest, you invoke it, and you get a binary. But let's say you want to do some tweaking on the resulting Go code before you build it. Let's say you want to run a sed script and do some minor replacements. This is also possible. There's a skip compilation flag that will just generate the sources. You can do whatever it is that you need with them, and you can build it yourself from there. Again, there's a lot of other options in the documentation, but I think these are the 2 that are the most important to know.
All right, so now we're going to look at an example distro. This is probably the easiest distro that you could have, like in terms of the components it has. We call it OTLP, and we release it officially. This could be used as a TLS termination proxy or some other kind of proxy where you change the way the protocol is working. If you want to learn more about why you would want to do that, you could watch the recording of a talk earlier today in the observability today called Encrypted Telemetry in Transit by Jason Plum. Right, so first we have this section where we define some build metadata about this distro. We need to give a module name that is a valid Go module, and then a bunch of descriptors about what this distro is about and the version that we're releasing that will be passed down to the different components. And then, of course, we need to specify the different subcomponents that are available in our distro. In this case, we're just going to have the exporters and receivers that speak OTLP, and then some way of passing our configuration, in this case through files and through the environment variables. As you can see, we specify them with a URL, which is a Go module, and then the version that we want from them. And we'll see how to do it for custom components later. Right. An important caveat here is that each version of the builder uses the matching collector API. So the collector has a set of libraries with which the components are built. For example, the latest version that was released just yesterday uses 1.2.3 beta and 1.29 stable. And so since some of the modules are still in beta, you may experience build errors if they change and there's a mismatch. We are working on stabilizing the collector APIs, so this should be less of a problem in the future, but for now you need to take this into account. And you could see something like this, where you get some symbols that maybe were defined in a previous version, but are no longer defined in 0.121 in this case. But so long as you use matching versions, this should be fine. OK, so we're going to talk about some common things you may want to do, and then move on to the more advanced use cases. So one thing that you may want to do is, well, imagine you have some component that you're using and has some sort of bug that the fix has not been released upstream. So you could use this replaces statement to replace the code of that component by a copy, a fork that you did that has the bug fix that you want. This is, fairly common. So we use it, for example, for our day-to-day development in the collector. OK, so now we're going to talk about how to build a production-grade distro. In this case, we're just going to have a distro with a custom component, and we're going to tell you how to release different artifacts related to it. So as we saw before, there are different kinds of components, exporters, receivers. These are written in Go. And the main thing that you need to know is that it's a Go module that exports a single function called new factory with a factory of the kind of component that you're building. This can live anywhere. For example, we publish our officially released components on the Go proxy. Usually, if you're building your own distribution, it will live in the same repository as your distro. And so now we're going to see the different files that our distro would have. We're not going to enter into the details of how to build a CAS component. That's a good topic for another talk. But suffice it to say, there's some Go code there that does what you want. In this case, we are building a receiver. And this is, as you can see on the left-hand side, within the components my receiver folder is where the code would go. So then how do we add this custom component to our distro? So we need to specify the metadata, as we saw before, and then the same mechanism that we use for hotfixes is something that can be used for adding your custom component. So you would add a replaces statement that would point to the components my receiver folder, and that would allow you to include this new component. This distribution with just a single receiver would not be useful. You need to at least build a whole pipeline, but this is for brevity. But imagine you add some other components from upstream. Once you have all of this on your manifest.yaml file, you would have to build your different artifacts. So this will depend on how your CA pipelines look like. In this case, we're going to use GitHub Actions. We will see how to do some of the specifics later with the OCB command. But you could use this GitHub action called the hotel distro builder by observe.iq, and you just provide the manifest, and basically it will build the binaries for you and release them through GitHub releases. So this could also be used for things like packaging. You want a Debian package or an RPM package, or to build Docker images. But we want to enter into a bit more detail about how these Docker images and other kinds of more advanced use cases would be built without using this tool. So now let's take a look at what the Docker file would look like for our custom distribution. We try to make this as simple as possible, so there are no runtime dependencies for the core collector framework. In this case, we just need to add our certificate bundle so that we can speak TLS. And then we can just create a from-scratch image, an image that does not have anything in the file system other than our collector binary. It's also good practice to run as not root. And yep, this is all you need to have a Docker image for your collector. All right. So now, how do you build without using the GitHub action? So you would just call your binary, so your OCB with the config flag, as Evan mentioned before, and you can use this command for more advanced things like building for other platforms. And you leverage the Go compiler for this. So you could use the GoOS and GoArch environment variables to build, in this case, for macOS on ARM. We support a wide range of platforms, so you can do Linux, Windows, macOS. We've even had people come and say, I want Plan 9 support or BSD. So yeah, if you're adventurous, you could do that. And then for more advanced use cases, you want to rely on standard Go tooling. So you could use Go Releaser, which is what we use upstream for things like defining the packages or software build materials. Yep. That is all we had. You can see the collector builder docs on the QR code on the left. And if you want to try the collector builder, you can download it with the QR code on the right. Thank you. Yep.
So I want to give a special thanks to the team at Bindplane for showing us their GitHub action a little early. But now I think we should have some time for questions, right?
Yes, we have time for a few questions. So if you have any questions, please line up to the microphone over there in the middle of the room.
Yeah, thank you for the great talk. One question, I get that the main usage for this building process would be to get a very low footprint version of the collector. So do you have any non-obvious tips or experiences from the trenches how to, let's modify or configure or build that the collector such that you can not even probably increase the performance, but mainly memory usage that is apart from what you probably already see in the docs?
That's a good question.
Yeah. I think it's a question that is hard to answer in general because the collector is very flexible in what you can do with your pipelines, and it will depend on what particular components you have. I don't know, Evan, if you have any generic advice here.
In general,
like to include, and then you see, well, that doesn't really fit the bill. You need to get rid of that in any case because it's very high, has a big impact on memory usage or something like that.
I guess one thing that we can mention is it is available today, and we're working on improving the internal telemetry of the collector. So you can observe using metrics, traces, and also profiles you can do with the pprof extension. You can see what's happening inside your collector, and you could use that information to optimize. I know that's not a very satisfying answer, maybe, but
no, great, thank you.
So I will say that by default, your collector binary, the Go compiler will do a good job of producing something that's pretty efficient. You don't need to pass any like GCC, -03 flags or anything like that. However, kind of like what Pablo alluded to, at runtime, there are a lot of things that you're going to need to pay attention to. If you're doing like tail sampling, you can build up a large memory footprint. That's a bit outside of the scope of what we have here, but if you come to the OTel Observatory any of the next 3 days, we'd love to talk to you about that.
Thank you very much.
Thank you.
Hiya, thanks for the talk. Got pretty much the same question. There is, judging by your answer, there is no benefit to cut down on the amount of the libraries I include in my binary for performance. If I'm not planning to modify the code base, there is not much benefit from the OCB.
So that's also a good question. I mean, there is, from the extent that, let's say you build every possible component you can into a binary, and that binary is, 500 megs. That's 500 megs that you need to transfer and load into memory to run, and et cetera. So there is that, but from a perspective of, outside of that, I don't think that there's really you're not going to get any benefit. Let's say you have a binary that's 20 megabytes, and then you add 25, add an extra 5 onto that. That's not going to have a dramatic impact on your runtime performance.
Right. Yeah. Other than the base level of memory usage because of the binary being loaded in memory, there's no significant difference.
Cool. Thank you.
Thanks.
All right. Do we have one more question? Yeah, we do.
Kind of late. Thanks for the talk. I have a question about the Prometheus receiver. With the company where I work, we have built the OpenTelemetry Collector with the Prometheus receiver, and we were surprised about the size on the disk and the memory footprint when we are just building and running the Prometheus receiver. The question is, there is a plan to have a lightweight of the Prometheus receiver?
I'm not aware of one. Pablo, are you aware of anything?
No. So we now have some Prometheus maintainers that have become more actively involved on maintaining the Prometheus receiver. They will probably be in the OpenTelemetry Observatory tomorrow and the next 3 days. So yeah, I think it's a question that you can ask us again within the next 3 days. Sorry, we're not Prometheus people. Asked you.
Okay, thank you.
Thank you.
All right. It seems we are done with questions, so thank you for the talk. Let's give a round of applause to our speakers.
Thank you, everyone.
Thanks.
Cool.